this microphone a little bit closer. Good evening. How are you all on this Friday evening? Or well, it's Friday evening over here. Oh wait, music's too loud. Let's try it like that. I'm still in the process of cleaning stuff off of my desk from the last video I shot, so I thought, let's do that now. Okay. Let's see here. Slicer Kasoit. Yeah, sorry if I butchered that, was first, but it was at 7:05 p.m. And then Draadstal said, yeah, PD trigger board test. Always wanted to know how many amps it can get through. Exactly. My thoughts exactly. So I ordered a bunch. And Jacco Wies, like this in the unboxing video. I think he's referring to the BoneIO. Still need to get that one. One of you didn't slam the like button. What? What? Why are you even here? Good evening, says Luke. And Robin, here's the music. James Derrick says, hello all. Nigel Young is here. And Gary F says, Friday afternoon in Michigan. No. Let's see how they say it in the movies. Michigan. Whatever. Can't speak English today, it seems. Okay. Well, welcome from Michigan, US. Draadstal has been left unsupervised. That is likely unwise. I don't know. USB PD dig to go incoming. Well, I've already done some design work on that. That's nothing new. But it's always worth evaluating new and different chips and solutions and things like that. So, yeah. But not just for that. The USB C PD triggers can be generally useful in that sense. Especially since the chargers are so mass-produced, they often get pretty cheap. Nowadays. Used to be different, of course. Oh! Johnny Bergdahl is here. Oh. I mean, the whole reason I didn't design it as a PD board to start with is because it was meant to be a low-cost controller, and adding the PD circuitry and extra power handling and upgrading all the components to handle up to 20 volts, etc., well, it would just increase cost. So it would always have to be a separate version in my opinion. But who knows, maybe there will be a Dig to Go Plus at some point, which can do 5 volt and 12 volt, or maybe even 20 volt and then buck down. Sadly, PD doesn't do 24 volt. And it will in the future, or it actually already does with PD 3.1. But then you're like paying $60 for a charger. Well, then you can better pay $20 for a charger that does 24 volt natively. So I don't see that making sense anytime soon. But you know. Yeah, USB-C is awesome. I like USB-C. I was having a discussion somewhere online today about Apple, and someone wanted to buy a new iPhone, and it started me on a rant about how they finally switched to USB-C and stopped abusing their customers with proprietary cables they ask the whole world kind of money for, while there's like $1 of components in there, if that. They still ask $30 for it because it's Apple. And I'm like, locked in proprietary ecosystems suck. Where's the Dig to Go AI Pro? Yes, I should start adding AI to all my products I've seen from all the Computex coverage. That will boost my sales with, well, I'll have to ask AI by how much, but a lot. Oh, you know why they're brighter? I didn't set them. They're not doing anything. Let's see. Let's choose a cool pattern here. Fairy Twinkle. Am I on the right controller? I think so. Yeah. Doesn't do that much. Actually, with the camera settings I have and all, I have to tone those down a little bit more. My chair, I moved it down for another video I recorded. Now I'm too low. There. That's better. Let's see, gradient. It's pretty cool. I think we had something like that recently. Let's see, Meteor Smooth, Multi-Comet. No, Meteor Smooth. Oh, wow, okay. I have to turn it down, because otherwise you don't see anything. There. I guess that's cool. Let's put it on random cycle. Okay, a little bit more brightness. Let's say that's pretty cool. It is now on Meteor Smooth, with a random cycle palette. So that was very astute from you there, Pius Karthik. Any good news on the analog pre-assemble board? Yes, they're basically done, ready to go. But we ran into a software snafu right at the last minute. Not so much in the software itself, but in getting it on the boards, flashed and tested. But the guy who does that for me at AllNet, he's currently on vacation. So that's why the project's kind of delayed right now. But it's all done basically. We're just waiting for that to happen, and then it's a full go. I have all the costs calculated. Everything has been produced and tested. Well, mostly tested, but I still want to do a full board test of all the boards, etc., etc. I've been using the prototypes the production models actually for over a month or 1.5 now, and they've been excellent. So that's all ready to go. So the AN Penta Mini is going to be here really soon. I think first week of July. So yeah. More than 40 people didn't hit the like button. Are there that many people here? Oh wow, there are. 54 people. Nice. Let me get the BoneIO. Oh. Nice. Sure, PS, that's fine. That's, I think more people were interested in that. Here it is, but we'll talk about that when the stream starts. We're just gonna open it up today, take a look inside, play around with it a little bit, test some of the functionality, have some fun with it. I can't hit it any faster. Well, if you hit it too many times, it also doesn't work, so... Slam the like button like the Hulk. But your poor screen will never recover. So let's make my drink, because today we're going to do something that hasn't happened very often on QuinBoxed. I was going to say QuinBoxed. This isn't the QuinBoxed. On the stream yet, we are going to take this guy. Why is this blue? Okay. And this guy. We're going to mix it up. So let me finish the rest what's in here. Oh, it started raining like 20 minutes ago here, and now it's stopped. So Draadstal and I live fairly in the same region, so we're going to take 1 part Sprite and 1 part Fanta Lemon zero sugar, and the Sprite is also 0 sugar. Actually, the Sprite is more 0 sugar. So this one doesn't say zero. Oh, it also says zero sugar. But zero sugar doesn't mean zero sugar like you think it means zero sugar. Because this is actually zero. But then the Fanta Lemon, it has sugar. Of which are sugars 0.5 grams for the whole can. So zero sugar does not mean no sugar. They're likely fruit sugars, but yeah. When will Diff Power be out? No clue. We're currently still in the prototyping phase. Diff Advanced is currently in production. So that will be first. And that is fully hashed out and working great. And so those boards are in production. But Diff Power is still very much in the prototyping phase. And we're still kind of stuck on some issues, let's say. Let the smoke begin, says MSX Droid. Hey there. So we now have the mixed drink. Because, you know, the Sprite already contains a bit of lemon lime. And now it's just more lemony. How long from production to shipping? Oh, that really depends on packaging, board information, testing, etc., etc. But we're working on most of those things in parallel. But it'll likely be somewhere in July also. Chai, yeah, I'm working on it. It's one of the projects I do want to finish and get working. But as of currently, as we've seen in the most recent live streams about it, it's not working. And I've been working on it behind the scenes, but I'm kind of stuck on the MOSFETs blowing, and I'm not really sure why. So it might need some more involved changes. Who knows? Oh, Pat Rooney is in the middle of house renovation. Need to plan for lighting. Sure, I get that. Well, Diff Advanced is coming, as I said. Probably somewhere in July. So that shouldn't be a problem. Diff Power, I just don't know. It's done when it's done. Oh, wait, I'm on the wrong screen. My girlfriend, who's sitting in the same room, just noticed me replying to my comment. You replying to my comment. And now she thinks I am ever so slightly cooler. Well, my pleasure. Okay, thanks, Chai. Full rewire, including KNX. Oh, interesting. Will we see multi-sensor from Quinled one day? Maybe if I design a sensor ecosystem. I don't know. Currently, that's not what I'm working on. Where is the CEO? What are you paying him for if he is absent? I don't know. Maybe he's watching soccer or football, as we call it. Seems that he's on today. I had no clue. I was just like, oh, let's go a little stream a little bit. So maybe the viewer count will be lower today because they're watching soccer. Maybe not. I don't know. Yeah, Philip is catching up on some sleep. Philip is also deep in house renovations, so yeah. So I still need to find my bit set because I don't know where it is. Oh, wait, that didn't come in one of those, huh? You know what? I'll just borrow bits from this one. That will likely work. We'll see. That's no excuse. Just log in and go back to sleep. Well, that won't get you a participation trophy, but Speaking of house renovations, any decisions yet about moving or not? Well, we still want to move. That's already been decided. But we had our eyes set on one plot of land but there's some stuff with the local government that still needs to happen, and yeah, we recently got word about that they finally had a talk with the local government, but that it's probably going to be August or September or October before that even continues. So no clue. We'd like to live on that plot of land, but it needs to become available first, and then we still need to buy it. We went to another one about 20-25 minutes away from here, and we went there twice, and in the end decided wasn't really our spot, or the rules and things like that. So yeah, Johnny isn't moving until August. Well, I won't even have land before then, so yeah. Not due to complete work until November, so I think I can just run Cat 6 and hope for the best. If you're talking about diff power, sure, I have every intention of making that work, but you know, sometimes things can't work, or I don't know. That's why we build prototypes and test things. On paper it's working great, and if you don't hot plug it, it's working perfectly. That's not the problem. The problem is that if it has an RJ45 connector, people are going to have to hot plug it. You can tell them not to do that, but they are going to do that anyway. So I have to design against that, you know. Jordan Reese has a slow work day, so can catch a live stream. Nice. Okay, well, it's 15 over. So has everyone seen the QuinBoxed with the BoneIO in there? It's the last QuinBoxed. If not, let's quickly talk about this thing here. Let me show you. So this is the BoneIO ESP32 x 10A. They have an ESP32 lineup and a black lineup, which has a BeagleBone Black in there, which is a little bit more powerful than an ESP. It's like a Raspberry Pi competitor in a sense, and it's a pretty big board. It's made to go into a DIN rail housing. It is nicely CE certified. That's cool to see. It's made in Poland. Well, I believe the PCBs are made in China, but then I believe it's assembled, and this is 3D printed in Poland. As I said, it has a nice springy DIN mount on there, so that's pretty cool. And then it has actually 2 levels, and I'm wondering how they did that with the headers and stacked stuff and things. I think I know how they did that, but we're gonna check that out. So the first thing I kind of want to do before we actually turn it on, wait, are we in 60 FPS? Oh. Yeah, okay, that looks 60 FPS-y. Is open it up, because I'm curious. So they seem to have used these Torx bits here, so I need to find a torque bit, but I don't know where the bits for the actual screwdriver is, but I have this set. Oh, well, no, oh, that's on the screwdriver. That's okay. Oh no, there's already one missing. So let's see if this one fits. Oh yeah, it does. And then let's see if I can use it on this screwdriver. I can't. Oh, it's pretty long. Oh, that's a pretty long screw. Of course, it has to go through 2 levels. Okay, no heat insert. Okay, so it's just in the plastic, so we shouldn't open it up too often. It's very sturdy though. My screwdriver is having a hard time with it. Yeah, it's lots of I/O. I mean, if you need some input and outputs, you just get one of these and you can, you know, wire up the whole house. So let's see. It has a maximum of 10 amps per relay, and there's like lots of relays in here. Okay, so we took the bottom screws out, So now let's see what happens. I don't know which part this separates or not. Is the case multiple levels? It is. I don't know if it's maybe also glued. Oh wait, oh okay, okay, this part is coming up. Oh, did I break it? No, it's just a scratch. Okay, so let's put it like this. So the bottom plate's coming off. Oh no. There is a, well, it doesn't say void warranty, but I had warranty until 2025. No, it's 20, okay, it was made in the 3rd of 2024. It's just a disclaimer for who missed the QuinBoxed. I got this unit for free after talking to the developer of it, who are in Poland, and I said, you know, I'll take a look at it in QuinBoxed and anything else. No promises, no scripts, no nothing. And well, I found it interesting, so now we're taking a look at it during the live stream. I asked him, or I invited him to be here, but he also said it's soccer. That's why I know. So I don't know if he will be or not. That's okay. So let's see if we can get this. Oh, we probably can't get this out. We need to remove these terminals. Pull the green bricks out, says Thomas Heavengard. Yeah, I think I need a tool. I don't know where that plier is. I have one plier which would be perfect for this, but then it's gone. Oh, maybe this one. This is a bit more robust than I was looking for, but yeah, see, this one can't grip it under there. Maybe this one. I don't want to damage it because it. See, now I'm damaging the screw terminal. Okay, I'll wiggle it out. I'll do the right thing. Damn it. Okay, maybe not. So okay, then we're going to try and do it like this. Oh yeah, that's okay. This is the way. This is the way. You take a really large flat bit and you just gently pull it away from the housing. There. Oh, now it's easy. Hey, I mean, it's a good thing they're secure. Okay, so now all of the top level are gone. Will this now come out? No. Okay, I think we need to separate this board from the top board. Warning. Down, down. Warning, down. Okay. Not sure what that means, but sure. I guess you can plug it in both ways. Let me see if it's a header. Yeah, okay. As I figured, they mounted it together. Oh, okay, using long pin headers. Interesting. Yeah, sure, I get that. And then the top board basically just has a header to which that plugs in. Yeah. Cool. Okay, we'll take a look at that in a second. So this is really clamped in there, but there are some screws here and here. Ah, because this can come off. This level also separates, I think, because that's also where the screen is. Wow, they put some great thought in this. Oh, there is Pavel Sazver. My pronunciation today is really bad. One eye on Euro, one eye on live video. That's okay. I appreciate you being here and, well, sending this over. I'm now in the process of dismantling it because I'm curious. Okay, it needs to go out more. No, that's out. Let's see if these need to go out more. No. Okay. Maybe we can use the tool now to get the screws out. Come on, screw. Okay, that's one. I really don't want to damage anything. Okay, maybe later. Yeah, there is a heart in the middle of the screen. We got it to go away once. Oh, screws flying around. And then it came back, and I don't know how to get it away. So now I'm going to try a little trick here. I'm going to put this in here, and then turn it and see if... Oh, no, I put it in more. Yeah, so that makes it come out more. That's good. Come on. Now it's stuck. Okay. It's almost out. Okay, more turning. Let's try it with just this one. There. I think that did it. We love your content, and so does the computer system. That's why you get a heart. So far, they've been using the same screws. That's really appreciated. I get it from a BOM standpoint too, but you know, sometimes they just... And these are all the same, I think. Yeah, okay. And then we have this one, but it's okay. So... this is clamped down, but now I think we can remove the top level. Maybe. I think. Oh, wait, maybe. Oh no, this level separates now. Wow. That's... Oh, but the sticker. Oh no. Hold on. I'm voiding all warranties here. There. Okay. Okay, so this goes like that. Okay, so this comes apart. Oh, wow. It's a really clean 3D print. And it's really, I mean, it almost doesn't flex. It's really sturdy. This top one is probably glued on, because there is a seam here, but you know, that's fine. Yeah, really nice construction. Okay, so now that level is off. So now this board separates. Oh, and this is just some middle frame. Really cool. I wonder how they get this on there. Is that 3D? Pavel, is this 3D printed, or do you have some kind of printing method to get it on there? It's really nice and clear, even though it's on a 3D printed surface. So good. Okay, so the Ethernet socket actually protrudes laser. Oh, maybe. Through the board. That's interesting. Oh, I see why that is. Okay, they didn't do their own ESP32 circuit. They're using one of those WT32 ETH1 modules, or 01s. Looks like pad printing. Yeah, maybe. So they're buying a pre-made module. So that has the ESP32 on there and the Ethernet circuitry, etc. And, you know, if you've never done those before, those can be tricky, so I get that. It's special printed. Outside company. Okay, but they print it on your 3D print then, or do they do the 3D printing with it in there? Okay, cool. So we have a little screen here that protrudes through the opening on the top, and it actually has some kind of bracket holder, and then I'm assuming it has some long pin headers again. Because otherwise it's just, you know, one of those default little screens. Oh, okay, so they print it on your 3D printed case. Nice. Cool. Yeah, it's really good because it looks really clear. I like it. I wouldn't know how to do that. I guess that's why it's a special company, huh? Yeah, it's good. So let's take a look at the bottom board first, because that likely has, well, it has the most components, but then the fewest types, because it's just repeating the same thing a lot. Now I can already tell you, this is where the weight of the whole unit comes from, because this is a hefty PCB. So let's take a look at the back. We see some nice isolation slots. So if you're running AC, at least it's isolated from the DC electronics. There's no isolation slots between the relays, but they're close together, so I kind of get that. And I believe for each plug there is one input and then two outputs. Well, we can probably also see on here. Yeah, so they have a common, so that's where you put in your live, your AC live, for instance. And then they have two NOs, that stands for normally open. And normally open means it's not connected, it's open, right? And so for each input, yeah, they have two relays, right? And as the top stated, it has 32 times a 10 amp relay. So it's not like you have one power input and then everything of the relay switches that. Each of these has a single input, and then you can switch two outputs with whatever you're inputting there. And I'm assuming it can be AC or DC. Let's take a look here. So it is a 10 amp 250 volt. So, okay, that's fine. It switched at 24 volt, it seems. I think that's probably what the 24 means. But it doesn't say any DC rating. The HF32FVG. Well, I could Google that, but you guys can Google that. Yeah. They have nice thick channels for load. And I think it's actually also tinned. So they have exposed copper mask, and then when it's reflow soldered, some layer of solder is dropped on those pads. Not much though. I think they did it to prevent heating. Max 30 volt DC. Right, so okay. Yeah, so you can do 30 volts DC max. So let's say 24 volt. And 250 volt AC, so 230 volts fine. Yeah. Cool. Anyway, these are exposed, but I don't think they're really tinned, or at least not a lot. But then again, they're very short traces, so even if you'd run 10 amps, I guess you could run 20 amps. I guess you could run 20 amps, huh? But then for 230 volts, or 230 volt AC, that doesn't make sense. No, wait. Yeah, you can run 20 amps. Because here in the Netherlands, at least, our circuits are 16 amps. So a normal housebreaker circuit is 16 amp. So here you wouldn't be able to do 2 times 10 amp on the same input. Yeah, the soldering looks fine. There's some flux here, or... Oh, actually, I think that's not... No, that's not... Okay, that's not flux. There is some coating here. Because there are SMD pads, but they're not populated. And I think to prevent solder from attaching to them during probably a... how do you call that? Waterfall reflowing. I forgot the term. I did a video about our production facility. Yeah, 230 volt to 20 amps, 4600 watts. And our groups, our house circuit breakers are 3600 watts or 16 amps. Reflow soldering. No, that's not reflow soldering. Damn it, I forgot the name. Oh, those pads are for cover version. Okay, so that adds some extra functionality. And I believe the cover version is for if you have window blinds that go up and down. So it seems they use the same board, but then they add some extra components to enable some extra functionality. Wave soldering, thank you. Did someone say? Yeah, James Derrick said it. Wave soldering, yes. So there's basically a waterfall that goes over the board and then solders all those traces. Although I'm not sure that process was used there. I think so. But anyway, PCB certainly looks nice. Let's take a look at the front again. The BoneIO. Okay, so I was going to say, I believe they use I2C chips because the ESP32 in no way has this many GPIO pins available, not even the S3. And the S3 has a lot of downsides, especially from when you use Ethernet. So I get they're using the normal ESP32 here. It seems they've made provisions that they can use two types of I2C chips. So they have the pads for both. And then they can select whatever is available, because especially during the part shortage, that was really a thing. For some reason, GPIO expanders over I2C skyrocketed in price. So, yeah. I am wondering how they do power to this bottom board, though. It has to come from here. Oh, wow, the pinout for the connector is over here. Let's see if I can get that focused. 24.5 3.3 SCL SDA, so that's I2C. Ground and then GS. I don't know what GS is. Okay, but we'll look at that more later. But I am wondering if they get all the power for switching the relays through these pin headers, because they must be pretty efficient relays, because I've seen relays that you latch on, so they're normally open, so no connection, and then if you close them, you make a connection. To keep it closed, it basically consumes power, and I've seen that be like 100 milliamps at 5 volt. Oh wait, no. Okay, yeah, so I was thinking that might be a problem for those pins, but these are probably 24 volt relays. So if they're 24 volt, the amount of milliamps you need is like 1/5 of if it would have been a 5 volt relay, right? Yeah, I'm MCP 23017. During COVID, those prices absolutely skyrocketed. You would pay like $3 for the bare chip. But the PCF 8574, I've also worked on that in some products. Those are nice. Those are pretty nice too. And there is another one, SX1509, I've also experimented with. I like those too. So yeah, I fully get being able to place both of them, because it sucks if you can't get the components. It seems like they're using an optocoupler for each of the relays, so that's nice. So that what they're likely doing is they're getting through I2C, they're using this chip to I/O expand, and one of those chips can do 16 channels. And they're putting this here, and they have a transistor, a diode, a resistor, and a capacitor. Okay, and then a optocoupler, and the optocoupler probably gets like 5 volt in, or 3.3 volt even in, maybe boosted to 5 volt using the transistor. And then the optocoupler outputs the 24 volt. And since it's not a lot of power, the optocoupler can probably just provide that. Let me up the lighting a little bit, because I have the feeling it's a bit dark. There, that's probably better. Yeah, and then they just repeat that like, 32 times. It's neatly laid out, that's for sure. It's nice. And since it's open hardware, they actually have the KiCad files you can see, or the schematics, or everything. So if something would break, you could actually replace it yourself if you wanted to. I don't know what this guy does. U30. Let's see if we can find out what kind of chip that is. Some kind of memory? No. An LM75B. I don't know what an LM75B does. Yeah, I was thinking the same thing, but LM75B. Oh, it's a temperature sensor. Okay. Yeah, it's an I2C temperature sensor. So this guy here is a temperature sensor. Cool. So they can measure temperature from this board, basically. Because this is in a bottom compartment. It's pretty smart. And since you have I2C anyway, you know, you can just tack it on there. Yeah, quality looks fine. Looks good. So you still have some pads available if you wanted to change the address of one of those I2C expanders. Maybe for different board configurations they use a slightly different you know, address. Cool. Well, okay, that's the bottom board. That has the 32 relays and is definitely the most of the weight. But it makes it feel like a good product, you know. Okay, so let's take a look at this top board. So we have the screen here, which is on a header. Probably should be able to just pull this out. There. Okay, yeah, so they have, again, some extended header pins. And then it's one of these standard I2C screens. Johnny Bergdahl wrote an Arduino library for the LM75A. Cool. So on this board, we have the ESP32, but as we already discussed, it's on a plug-in module, basically, that they buy probably in bulk, which has the ESP32 on there and Ethernet. We have the button here. There's a chip here. What is that? Oh, it's a Max 485. Okay, so that is for RS485 probably, and then the other one, that's a VP230. I'm going to guess is for CAN bus. Yeah, because CAN is right here. The CAN outputs are right there. So I'm thinking this chip is for CAN, and this one here, since A and B is over here, is for RS485. They have some PTC fuses here. I think that's 1 amp. Yeah, because the voltage isn't that high. Okay, that's cool. Oh, they probably have the PTCs on the RS485 bus. Nice. Some extra protection. Is this interesting? I'm just analyzing this board for myself. So I hope you guys like that too. Okay, so more I2C expanders, but then for the inputs. Where are the LEDs? I don't know if there is. I haven't turned it on yet. I literally haven't turned it on yet, so I don't know if there's LEDs. I think there's LEDs here, though. Yeah, those are LEDs. So see those D here, and that one, and that one, and that one, that one. Those are LEDs. So there are LEDs on there. We just have to see how they shine out. I don't know. So these are the inputs, and there is a switch here with which you can say if the switch or the input should be high or low. And I haven't read the manual, or at least not close enough. I would like it to be pulled high normally, and then if I short it to ground, to activate. So I'm thinking I need to put it on the 24 volt setting then, so that all the outputs are 24 volt, and then if I short it to ground, it activates. Please review the whole PCB. That's why I'm watching the channel. Okay. Okay, good. So let's see here. We have the main input connector here. That's for 24 volt. Why is that? Did it smoke already? No. We took it apart before turning it on, because that's, you know, that's the way to do it. Okay, so there is another input fuse here. Good. And there's a diode for reverse polarity protection probably. And since there's a buck converter on there, they don't need to bother with MOSFETs and things like that. Okay. There's an inductor here and an inductor here. Here's a very tiny chip. But there's a chip over here too. So I'm thinking they might have 2 buck converters on there. Wait, what chip is this? The 1219A. 1219A, yeah. Buck. 1219A. Okay. Oh no. Ah, that's a power measurement chip. That's it's I believe the I219A. Yeah. I believe that's a power measurement chip. Not 100% certain. Can I find the TI page? Yeah. A 26 volt, so that's why 24 volt input, 12-bit I2C output power digital meter. Yes. Okay. So output power is going through this, it comes in, goes through the PTC and diode, blah, blah, and then it has a measurement resistor right there, and then it goes through this, well, it goes through the resistor, not through the power measurement chip. Okay. So they can measure how much power the board uses. Still haven't got my strip working. It refuses to draw power. Okay. Why do I prefer the outputs to be 24 volt? In logic land, if something is defined as high, it doesn't really matter if that's 18 volts, 20 volt, or 24 volt. That is all high. But if something is defined as low, low is basically 0. But then you have to build in some tolerance. So you say low is 0.8 or 1.2 or, well, whatever. But in my opinion, it's easier to say anything above 12 volt is high than saying... But you can't say anything below 12 volt is low. Because you just don't know what low will be. So ground isn't 0, basically. Right? So it depends on the cable length and things like that. So I prefer everything to be pulled high. So then it's easier to detect a low than to detect a high, basically. In my opinion, in designing the circuits. So that's also why my button inputs on all of my boards are all pulled high. Now they're pulled high to 3.3 volt because I don't have optocouplers and things like that in there. There's reason to do that for house installations. And that's 0. Less issues mixing supplies, sure, that too. Anyway, that's my reasoning for also using pooled high inputs, because I just like that better. It's easier to detect a low than to detect a high, in my opinion. Okay, so then they have this tiny little chip here, and then a bigger inductor, so that likely makes the 5 volt from the 3.3 volt, and then something over here, or from the 24 volt, and then something over here probably also makes the 3.3 volt. Well, maybe this guy. I don't know. Let me see if I can find what this chip is. A 4202. What? What's a 4202? That's probably production date, so we won't be able to find the buck converter. It's okay, there's like a gazillion buck converters. Oh, it's a TPS 54202. Probably. Very most likely. Let's see for specifications. Hold on, I have to sneeze. I'm sorry. That is a 4.5 to 28 volt with 2 amp output. Sure, that should be plenty. Nice. Big cap here. Oh yeah, there's a 5 volt LED there, so this buck circuit is likely making 5 volt. I don't see a 3.3 volt LED. Oh, I do. That is over here, it seems. Or at least there is 3.3 volt present over here. So that might make the 3.3 volt. Yeah, and then the inputs are all run through optocouplers. That makes it very nice and safe. that's mostly it, I think. RX and TX are here. There is the auto programming. Oh, wouldn't need that many pins for that. Yeah, that's true, James. Yeah. Because this one doesn't have a programming circuit, so they would have to add that. But then, where is the chip? Ah, it might be underneath. I'm just gonna... There we go. Right, prog, so it's programming. And then this is probably a CH something. Yep, it is. Hold on. The CH340K. Yep, okay. So that is the USB to serial chip, which enables programming, because this one doesn't have that. I don't like making boards that don't have that, so it's really cool they added it here. That's good. And then there's another chip here. Let's see what that one does. The DS1307. I know that name, but I don't know from head what that does. DS1307. Oh, it's an I2C real-time clock, it seems. Okay. And then there is a pad for a battery on the back, but it's not placed. Okay. Maybe it can store it in the chip. I don't know. And I think that's most of the board. I don't know what these two guys here do. Yeah, the auto programming circuit is here. What does it say? Can I see if there's anything on there? They are identical and they say C5J. No idea what a C5J is. Sorry, I'm picking apart your board here. Oh, I think it's is it some kind of level shifter? No, it's an XOR gate. Okay, right. So it's a logic gate. So they can do some logic with those gates. No, there's no ESD protection on there. Although that might be on... No, this is the USB-C plug. No, I don't think there's USB... Maybe there's another little bugger over here, but that's probably also a XOR gate. They do have a PTC fuse, so that's good. And there is a diode there, so I'm assuming it doesn't allow positives to connect. Like if we have 5 volt coming in here, or being made here, and then also coming in here, I'm assuming it blocks that. Yeah, pretty cool. Okay, let's line this up and start putting it back together. But all in all, this is a very... Somebody spent some time designing this, I can tell you. And I'm thinking it's likely 4-layer at least. Yeah, because you need to have power planes over here. And all kinds of routed signals. And some more planes and vias and things. Yeah, this is at least 4-layer. But it's very nice and neat. Nice selection of chips. Relying heavily on I2C, but that's basically also the way I would do it. So... yeah. Noise. So far, it's looking great. I think it'll keep looking great, but you know. So I think we need to start building it back from the top down. So this needs to go back on. There. I don't think we'll actually be able to get to see these LEDs, because if we look at this top cover, there is vent holes here, but they don't really line up with the LEDs, so I don't think we'll get to see the LEDs. Do we want to turn it on before we put it together? Well, there's still not any evidence we'll get to see the LEDs, because I don't know if they're programmed. I kind of want to put it together first, so let's do that. So I believe we start with the top cover, and we need the button. So let's lie this down. Right. Let's see if the button aligns correctly. Sounds like it. Covers? Doesn't need covers. I'd rather put it back together and then see how it's, you know, intended to function. And then I believe this aligns with these slots here. You have these. Yeah. Okay, and okay, and that also pushes the PCB in, so that's nicely held tightly. Yeah, somebody spent some time designing this. Trust me, I can tell. If you do this work yourself, you can definitely see when someone spent a lot of time on something or they just winged it. Like, remember those LED controllers we looked at a while back? Some of those designs were really winging it. Like, I read in a textbook you're supposed to do it like this. They never tested it. I can guarantee you they never tested it. Yeah, exactly, Willem voice. This is not your first model. So let's try and put this together. And I know how much trouble it is to make a PCB and a housing and have it all line up and make sense and not be in the way of the other thing and be practical. And oh man, there is a lot of time and effort that went into that, I can tell you. And maybe someone would fault them for like, but yeah, it's a 3D printed enclosure. There's 3D printed enclosures, and then there's this thing. This thing is really nice. I wouldn't mind this at all versus a normal enclosure. As long as it's, you know, well put together and sturdy, I don't care that they're 3D printing. I know how much injection molding costs, because for instance the Dig2Go is a custom injection molded product. Yeah. You need to know that you're going to sell thousands and thousands, because otherwise, don't bother. Okay. I think that's good. Yeah. Button still works. Okay, screen's in there. Solid separation between high voltage relay and low voltage input PCBs via the case. Yeah, exactly. These can never touch. So now we need to remember bottom, because it said bottom, bottom, bottom. Right? It has all those arrows. And this is the bottom, because that also has the power input. So I'm going to turn this around like that and put it on here. And I think we just need to align it there. Yep. I think that's connected. Yeah, nice. Yeah, I mean, this can never touch. It's great. It's good design. And then we have the bottom piece. And this one doesn't say bottom, bottom, bottom. I'm not going to DIN rail mount it anyway, so I'm just going to do... Oh, wait, I can align it with the sticker I removed. Later, Johnny. Thanks for being here. Okay. I'm missing some alignment here, or do I just need to push more? No, I probably need to get the PCB exactly in these, yeah. Ah, and there's alignment in the case too. There, okay. Yeah, that aligned. Okay, good. Okay. This one doesn't want to go in. It goes in but snugly. Let's try this one. I'm going to use it as a normal screwdriver. Because you're tapping into the plastic, so that resistance is expected in my opinion. Yeah. I mean, it's not really intended to be taken apart, so I'm fine with it not having metal inserts. Nice squeaky noises. Okay, one last test. Okay. Oh, it's ABS. Okay. Well, that makes it even sturdier, so. Yeah, I don't know if the clips are printed too. No, I think the clips are... the clips aren't printed, or maybe they're resin. I'd say the clips aren't printed, but Powell knows. The rest of the enclosure is, but they use some nice ironing also, like on the top surface. You wouldn't know it's 3D printed if you looked at that. Just on the sides, you can see the layer lines, but they're very fine. They're very nice. And detail's great. Check on the website boneio.eu, Nigel Young. This is the 32 × 10. So let's plug these back in. And let's turn it on for the first time. Because we took it apart before I ever turned it on. But, you know, I like judging hardware. And the hardware looks great. And this all lines up. That's nice. USB-C. Ethernet. Yep. Nice. Made for ESP Home label. Yeah, I still need to pursue that for the analog dimmers I'm bringing out. Because they do work best with ESP Home too. So certifications, at least it has CE, and I believe Powell mentioned that they're working on US certifications. But CE is a big one. CE is much more strict than any US regulation, I can tell you already. So yeah. So if you pass CE, you're probably going to pass ULCSA. Yeah, I'll do a reinstall with the installer because I also wanted to show the installer, so that's fine. We'll do that on first power up. So I want to power it up with some power to just see that it turns on, and then we'll turn it off again. We'll flash it. So let me prepare some power. But I got a new power adapter out, and we still need to snip it. Because I don't like using barrel jacks, seemingly you don't either. Oh. So this is a 24 volt 2 amp power brick. The AliExpress jobby, but I know it can deliver the power, so that's good. Let's see, is this my multimeter? Yes. We need to get it back. This thing runs ESP Home from factory, Willem, so I believe everything, especially on the I2C bus and etc., is all supported. So if we look at the power plug, we have plus on the left side and ground on the right. And if we look at this cable, I believe the one with text on there is plus and the one without is ground. But we'll test that before we plug it in. So let's do this properly, because I use these adapters for more things. Oh. Yeah, if we're on LAN, no, everything is in different subnets on my side. So we'll have to add it ourselves, but that's okay. You can't help that. But my Home Assistant server is in a own VLAN, and my Wi-Fi is a different VLAN than my Ethernet, and you know everything has separate IP ranges, etc. So let's see if these fit. I think so. Yeah. Okay. Can we go one smaller? Can we put white ferrules on there? That'd be great. Oh, we can. Nice. Well, I didn't strip it far enough, but it's okay-ish. And I know with these kind of terminals, because I use them myself too, I don't need to use ferrules. I just like using ferrules. Okay. Right. So I'm going to screw it in the way I think it should be. And that is with the text one, which I think is positive on the left. Oh, it's a kitty. Hello, kitty. Okay. It's funny, his name is actually Kitty. Well, your ferrules shouldn't determine what that side is. But what we're going to do is, I'm not going to put it on screen. We're just going to measure it. Okay, let's plug it in, power it on. Good, my cheap ass adapter didn't explode. Let's see here, some leads. So we need left to be positive and right to be negative. $24.7, and it is. Good. Okay, so let's turn it off. You shouldn't hot plug things. There, let's plug it in. And then let's power it on for the first time. Oh, I can see some LEDs. There's some red LEDs in there. Those are probably those 5 volt and 3.3 volt LEDs. BoneIO, take control of your home. Let's see if I can synchronize to that refresh rate. That's probably as good as it gets. It's flickering a little bit less. Let me take a drink. I didn't do a good job of screwing this in. See that? Okay, so I don't know if the screen will... Oh, okay. If you push the button, BoneIO, it doesn't know the date because it doesn't have network right now. Temperature sensor already shows up. Uptime, IP address. Oh, okay, the current. My adapter says it's using 2 watt AC side. And then on the DC side, I guess it's 0.83 watts. And it's measuring 24.45 volts. Okay. Yeah, that's nice. Okay, so the first thing we're going to do is flash it. Let me improve this connector here. Kitty hairs. Okay, so let's unplug power. Let me prepare a browser so you guys can watch along. Or I guess I can share a whole screen. So let's see if I can share a whole screen. Yes. Okay, so let me enlarge that a little bit. If you go to the BoneIO website, boneio.eu, you can find all the documentations and the store, etc. Let's see if I can find the installer. He's made for ESP Home. That's nice. Home Assistant, MQTT. You might still be hearing a kitty, because as long as I keep talking, he'll stay around. Let's see. Can I find an... Okay, maybe I should go to the board page. So you have the BoneIO ESP, but that's actually a category, because we have the BoneIO ESP 32x10, but you also have the cover mix, the ESP cover, and the 24x16. So that's a more powerful version, I guess. So let's go here. Oh, it's 413 euros including tax. Okay. I mean, yes, it's an ESP you can buy for $5, and people often compare it to that, and they do that with my controllers too. But you build. Oh, you can't even see me. Hold on. You try building something as well compact and well functioning as I am currently assuming this is, versus like what you cobble together on your breadboard. That's just worth some money. You can do it yourself. You can get all these components yourself. The components are no secret. I mean, even for like my boards, I tell you how to build DIY boards. And even make the designs for that available. But that's not the reason things cost money. You know, things need to be developed. They actually need to be made, and you need troubleshooting and production facilities and testing and documentation and all kinds of things. And certifications cost a lot of money. Kitty, we can't play right now. Play later. Oh, okay. So, sure, that you can buy all the components yourself and cobble it together on a breadboard, in my opinion, just like the LED controllers, that's not the same thing as this is. And, I mean, if that's what you want to do so, right? I think the price is pretty fair for all the hardware that's in there. Because, I mean, you shouldn't forget, there's 32 relays in there. Let's say those are like $2 or $3 a piece. Well, that's already a big chunk of the price. And then there's all the other chips and hardware, etc. Everything has a price. So, yeah. Oh, Stefan Menes is here. Wow. It's a Dutch kitty you're speaking English to. Yeah, it probably doesn't understand. But he did leave. So I'll have to give him head scratches later. Anyway, let's see if we can find the installer somewhere over here. I know they have a dedicated installer website, but I just don't know where it is. Maybe it's in the documentation that I so carefully still have lying here. /ESP is the URL. Oh, okay. So boneio boneio.eu/ESP. Oh, yeah, okay, that's right. There we go. Kitty didn't understand English, Dutch cat. Yeah, yeah. Okay. Well, let's connect the board first. Let's turn on USB there. And plug in a cable. I'll show you. It's not very interesting, but I'll show you. So, you plug in the cable here. This is a very chunky cable, so it's good. It accepts that. I heard a Windows chime. Screen seems to boot up. That's okay. We have a BoneIO ESP 32x10. Okay, next. Oh, which board version? Oh, we need the documentation again. Because on the documentation it says I have a 0.6 is my input board version. So I'm assuming they mean that. So we'll go for 0.6. And do we want to go for lights or switches? Let's go for switches. I don't know. Okay. And then we can download the YAML. Let's do that. Okay, so we go to the GitHub where the YAML code is. We'll take a look at that later. Let's go back here and do install firmware. It's probably this one, I think. Yeah, install ESP Home. Sure. I just remembered that I was supposed to update my testing Home Assistant installation before the stream. Guess what didn't happen? That shouldn't be too old. Well, this always takes a little bit. I believe so, Patrick. And I'm not even sure that is PWM. I think it's just a configuration for this board. It doesn't change the functionality, just a configuration in ESP Home. These outputs will always be on-off, no dimming. Yeah, that's the only reason I kind of agreed to take a look at this, Willem. Because it's all open, and you know, I appreciate that, and they're kind of like a startup like I am, making hardware and promoting it and supporting it. So, you know, I thought I'd give them a shot. Okay, so ESP Home is installed. So let me disable this one again. Does it say version here? No. Okay. Oh, the display actually changed because there's now a space between the Bone and IO, and there wasn't before. Cool. Okay. So we don't need USB anymore. Yeah, no, you can't PWM a relay. That relay would have a very bad time. Hold on, let me clean this up. Does the I2C and the Dig Octa still work normally without doing any hardware changes? Yeah, the onboard temperature sensor also uses an I2C, so yeah, for sure. Relay goes brr. Absolutely. Okay, we need some Ethernet. I think I should have an Ethernet plug here, maybe not. Let me try and see. Yeah. Because this thing basically assumes Ethernet, not Wi-Fi. That's okay. I can get behind that, especially for like if you have this many switches and everything on one board. Let me uncoil this. Okay. Ethernet is over here. There. And then I guess we should turn it on and see if it gets an IP. We're not going to be able to do the normal onboarding. Oh, no, it immediately got an IP. Okay. Weren't there 3 menus before? I don't remember. Sure, okay. So let me get my test Home Assistant ready. Yes. Okay. So if we go to Home Assistant, and in the bottom left corner we have settings. You can't see it, so let's go to settings. No, just 2. Okay. Yeah, the temperature sensor is on the bottom board. Oh, yeah, I'm pointing at it, but you can't see that. But we found the temperature sensor on the bottom relay board. You know what I also like? They used one of those terminals which have lights on there. It's an optional thing, but I really like that. I hate boards that don't have that. Yeah, I don't know if they have a solid state relay or, you know, different type of boards, but with these kind of mechanical relays, I don't think that's a good idea. So let's see. I think in theory we should be able to go to devices, add integration. It's an ESP Home board. We know the IP. But I don't know if they put a password on there, so we'll see. Oh, okay. Created BoneIO ESP 32x10 switches, blah. Oh, this is probably its MAC address. Okay, finish. Now, please don't pay attention to my ESP Home list over here. This is my testing Home Assistant. That's different from my production Home Assistant. Oh, okay. Because there's lots of stuff here. I mean, okay. We have the BoneIO ESP 32x10 switches, blah. Okay, let's go to here. Oh, we can activate the buzzer. Temp password. Oh, okay. Should we activate the buzzer? Okay. The buzzer works. Nice. Okay. So we have switches. Okay, so those are the outputs, the output switches, and they asked us if we wanted lights or switches. Now it's configured as switches, that's fine. And, oh, and then we have in, and those are the input sensors. So we'll measure if there's 24 volt on there or not. Okay. We're getting 24 volt in. Our current, okay, we can measure the current, the power. Oh, okay. Okay, 1 watt. The temperature sensor. IP address, serial number. Okay, uptime. Yeah. So let's see if we can switch a switch. Yeah, I heard a click. Let me turn the music off. Hold on. Let me... I'm a sucker for good clicks. You can hear the springs in there. That's cool. The music is loud today. Okay. It's good that you say to me. Do you tell me? Then I just turn it down. There. Okay, so the relays are working. The buzzer is working. We need to record what relay makes what noise. Yeah, exactly. Okay, so okay, I'll activate my overlay. There. Now you guys can also see the multimeter. Let's see if they're high or low. How would I know that? Okay, let's go to ground. Okay. Hold on. So I want to know if these are now high or low, basically. So let's put a probe on ground and on in 1. Okay, that doesn't do anything. VDD. No. Okay, if I change this around, doesn't do anything either. Okay, so if I put the inputs on ground, so now the switch is on 24 volt. Let's put it on ground. Does that change anything? No. No, no. Okay. So maybe then we have the VDD. Okay, there's no VDD here. Maybe we need to, you need to put screw into measurement what?
They talk about another kind of word.
You need to put screw in to measure anything? Really? No, these terminals I should be able to just measure without having to put anything in there. Yeah, because this one I can measure. Of course, that one's clamped down.
Well, here goes nothing.
Really? I think they're all the way up. Yeah, this one's up. This one's up. Okay, so let's put one all the way up and one all the way down. Okay, so let's try this again. Ground. This one. Nothing. This one. Oh, there we go. Okay, so when it's screwed down, we now see 23.5 volt on there. And the inputs is currently on ground. So the switch is on ground. So let's move that to... oh, you can put it in the middle too. Oh. Okay. So now let's measure it. Well, this one, of course, doesn't do anything.
What are you afraid of?
Yeah, so now it's not measuring anything because the switch is on 24 volt. Yeah, so you need to pull it high to 24 volt to trigger it. And if we move this switch, now it should measure 24 volt. Yeah, so now you can pull it down to activate it. Yeah, I didn't realize that, but yeah, it kind of makes sense. Thanks, Peter. So then what does the middle switch, what does the middle position do, Powell? Does the middle position switch it to VDD so that we can have different voltages here? Because I see the VDD terminals, but when are they used? I'm thinking middle might be VDD, but then this thingy doesn't show that. Read the manual. Okay, no, it's either plus or ground. VDD is either ground or plus. So then this would now also be okay, that's screwed down. So then this would also be 24 volt. No, it's not set to. Yeah, no, it's 24. Nothing. Okay. Then what does VDD do? I don't know what VDD. The middle one's not used. Ah, okay. You spelled fine wrong. Measure VDD and in2. Okay. Oh, that's also 24 volts. So VDD in this case is ground. So VDD always corresponds to what you've selected as over here, right? Okay. Cool. Okay. So then we should be able to, I don't know, grab this fine cable over here. And if this is now ground and this is high, because it's set to ground over here, so activating it needs ground, and VDD has become ground, okay. So then we should be able to go to the software. Let me... No. Yes. No. Hold on, I need to work this out. There. Okay. So we take our wire here and we cross it between VDD, which is now low, and in2, which is now high, and it turns on. Oh, and it automatically also turns on the relay. Okay, so let's scroll up to the relays. Oh, it's still on. Why is it still on? Did I turn it? Okay, let's turn it off. VDD. Oh, it's probably a toggle switch. Yeah, okay. So if I touch in2, it toggles relay 2 to on. And if I touch it again, it toggles it to off. Now, of course, that is the default behavior. You can specify this any way you want to. But the way it's currently working is that they've pre-programmed actions in ESP Home so that if in2 is toggled, the relay number 2 will be toggled, and if it's toggled again, it will be toggled off. But that will work independently of Home Assistant. So you can make automations in Home Assistant, but then if Home Assistant isn't reachable, or it crashed, or it's down, or whatever, this board will still function autonomously, because all of those things are happening on the ESP itself. It doesn't need network communication to do that, right? So that's a good thing. It just gives you flexibility. I have all my automations running through Home Assistant. I barely do anything on an ESP itself. Often I have automations that span multiple boards, like input is triggered here, make that LED blink, but that LED is in a whole different room on a whole different controller, etc., etc. And then, of course, doing it in ESP Home wouldn't work because it's interboard. You don't have interboard communication. You have that through Home Assistant or maybe MQTT. But if you really wanted to have like emergency lighting, which would still work if your server crashed or whatever, you would connect a bunch of buttons to here, and then you would connect a bunch of lights to the output, and that would be independent from Home Assistant. And then other buttons could be dependent on Home Assistant if you wanted it to trigger automations of whatever kind you wanted to do. When you turn on a switch, do you see an LED light? Let me see. So, switch is... Oh wait, no, switch... No, relay is on. The relays didn't have any LEDs and I can't see any. But let me see if I do this. If I see an LED turn on. Hold on. I do actually. Yeah, those won't work. Okay. I need to screw these down, but I think there's red LEDs in there corresponding to each port. Well, I was just kind of explaining that, Nicholas, that you can use it for input switches and then switching outputs. Yeah, that works. And yeah, there is an LED corresponding to each input. The switch in HA, well, sure. But that's the beauty of an open platform. You can configure it any way you want to. If you don't want to have that behavior, sure. I mean, yeah, as I said, most, if not all of my automations and switches and everything run through Home Assistant. That's why I have HAHA. So I have high available Home Assistant or Home Assistant high available, that even if my server crashes or my power supply burns up or whatever happens, there's 3 or 4 nodes actually running right now. And another node will just take over the most recent snapshot of 50 minutes ago and Home Assistant will be running again. So, yeah. I mean, look LED lights. No, yeah, there are LED lights on the board for the inputs. I guess I could show you like this. I'm gonna try. Oh, I know how to do that. Hold on. Yeah. Okay, so now that's in. Let me try and show you like that. And yeah. So if you look closely over there, you can see an LED. And if I do another. Yeah, that works well. Let's see, turn that one off. No, wrong one. Yeah. Cool. Yeah, and the way it's laid out is that you have blocks of 7 inputs and then 1 switching pin. So these are either pulled high or low depending on your switch, and then this one will be the counterpart with which to short it, basically, to activate that switch or that input. No, well, currently, no, I don't think the LEDs are in a GPIO. Actually, we can take a look at that, because if we go to a different tab over here, I need to expand this. Okay. Can I make this go away? Yes. Oh, okay. This is the current ESP Home configuration this board is running. So we can see some substitutions. It gets a Oh, okay, there we go. It gets a default name, and it gets a prefix, okay, and then some ESP Home name, friendly name, add MAC address, so it adds the MAC address of the Wi-Fi chip or the Ethernet, so that it always has a unique name, basically. I did a live stream on the finishing of HAHA, Gary. This connector is perfect for Ethernet cable Cat5e and Cat6. Okay. Ah, okay, like that. You mean if you're connecting the switches, you can use an 8-pin cable like a UTP cable to run the switches to wherever they need to go. Okay. But back to the configuration. There's a project name, version 0.6. It's a Node MCU. So it's just a generic ESP32 board. Then we have the Ethernet configuration part. Okay. It's going to import some stuff. So probably some latest code. It's going to inject into this code, basically. The same with like the display for the time, for the I2C, for the current sensor, for the temperature sensor, for the I2C port expander, and the generic board configuration for this board. So it's pulling in a lot of pieces of pre-configured code, basically, setting the GPIOs and things like that. You could also adopt device and ESP Home add-on. It's a pretty cool process. Oh, okay. I'll take a look at that. But let's go to the config. So it enables the logger, the API, and the OTA without a password, but you can always add that yourself. It has a web server. Okay, that's cool. Okay. Then it pulls in time from Home Assistant. I am not in Warsaw, but I guess that's where you're from. But as I said, this is a pre-configured configuration, and you can easily change those things, you know. Okay, it writes that to that time chip that's on there. And then we have the switch configuration. So we have output, switch 01, and that is on out 01, and ID is switch 01. Okay. And that is probably predefined in this YAML part, which isn't, you know, it's a nested YAML basically. So all those ports are defined in this board layout. So they define switch 1 and in 1, etc. And then they're calling it here. So you don't really have to bother with all that configuration. That's already done. Here you're just defining the switch and how it's called. Okay. And then it likely also has an input section. Yeah. And then it has an input section, binary sensor. So it's an on-off sensor. In 01. It's on the PCF. Okay. It's inverted because it's likely pulled high. And then here is the action that the onboard device does. It doesn't need Home Assistant for that. It does on press, then switch toggle, switch 01. So that basically says if in 1 is toggled, turn on, or sorry, not turn on, toggle switch 01. So if it's off, it turns it on. And if it's on, it turns it off. And well, it repeats that for all of the inputs and links that to all of the outputs. But you could easily say, okay, if in 15 is toggled, I want 5 switches to turn on. Or I want these 2 switches to always turn off and these need to be toggled. Or that's basically up to you to design the configuration you want it to have. And I said you can do that with automations in Home Assistant, especially if it links, if whatever you're trying to do is linked over multiple boards, then you'll need to do it through Home Assistant. But if it's linked on this board, like I said, you can have emergency lighting on 7 of the inputs and then 7 of the outputs. That'll always work. And then the others can be switched to a Home Assistant and be more advanced automations and things like that. Okay, let's see what else is in here. Okay, you can enable Modbus. Okay, so that's pre-configured, but it's not turned on. Okay. Okay, there's Modbus stuff in there. Okay. Okay, so let's take a look at my ESP Home add-on. See what version it is. ESP Home. Oh, I'm running 24.5.5. So in theory, that should be high enough to adopt it. Okay, so I don't need to update it. Let's just go to ESP Home. New device? No. So, as Pavel is saying, since ESP Home 24.5, I have 20. Oh. Oh no! Wait. No, sorry. Sorry. I have 2024.5.4. You're right, but yeah. So that should still be high enough, right? This is just a fixed release. I do have special VLANs. This test Home Assistant is in its own VLAN, separate from my normal LAN I plug into, separate from my wireless, separate from everything. So no, it won't be able to auto-detect that. Is there a way I can add it just by IP number? No, I hate MDNS. So I absolutely will not have an MDNS repeater. I don't make multiple VLANs and subnets to then just bridge them again. I don't understand why everyone does that or wants that. But I guess that's a whole discussion point, but it just doesn't make sense to me. I have a separate subnet for my wireless because I don't want my broadcast from my LAN stuff or my IoT stuff or whatever to go on my wireless subnet, for instance. But then if you start bridging everything again, it doesn't make sense to me. No, so I don't have that. Okay. I wish they'd just, allow you to input an IP number. I get they want to use MDNS for new users and users who aren't network savvy, but all the people who are network savvy, they basically tried to leave out. The same thing happened a few years ago when they broke everything when they switched to MDNS. And they've now almost fixed it by allowing ping for status updates and things like that. But if this new adoption only works with MDNS again, yeah, stupid. That's not, just to be clear, that's not BoneIO's fault or Powell. That's just how ESP Home works. I just don't like this focus on MDNS on everything. I mean, I get it works in the most of simple home networks, but if you have anything more advanced than that, it breaks everything. Sorry, it's kind of a pet peeve here. Yeah, but if you pick up the packets from one subnet and then just broadcast or send them out again on another subnet, then why have a subnet at all? I believe Apple started with it with Bonjour, but that's a lot older. But it basically does the same thing. So we won't be able to adopt this controller. However, what you would do is you would just take this example configuration from the GitHub here, and you would just copy and paste that into into here. So this is the test BoneIO YAML that I just created. We're just going to Control A, Control V, and overwrite that basically. Oh wait, I just thought of a method we could actually do it. No, okay, so normally you'd have to have a DNS name, which is also this name. Yes, but that's not going to work because I don't have that name in my DNS. If you'd have MDNS, you might have, but I don't. But there is a trick for that. So let's save this test file that I just copied from the GitHub. And I need to go to a different board. So you can do two things. You can set a manual IP, but we don't want that. Our DHCP IP is fine. So I need to borrow some code from one of my testing setups. Maybe this one. Yes. Okay. There is a command you can do is say use address, and then you can tell ESP Home. Where is my test? Oh, oh, yeah. Okay, yeah. We should be able to put that here. And then use the address that our BoneIO OS has, so 10.10.128.106. And then I'm just going to save this config. And I'm going to hit install. And do it wirelessly. And because I put the use address... Oh, I might have to close it down. Yeah, I could have made a stat. That's how I often do it. Make a static DNS entry and then have reserved DHCPs. But I'm just showing you how you can use the use address in your YAML code to adopt something that has gotten a DHCP address in ESP Home. But I didn't back out of the configuration, so I'm not sure it took it. Yeah, okay. So, because I put the use address in there, although I don't have the DNS name of this board, with use address, you can force it to use an IP number in the configuration of ESP Home. Because I've been having to bypass all this MDNS crap for like years now. Yeah, so I know how to do that. So even though the configuration is on DHCP, so it will request an address from my DHCP server. Because we have this button here, I can see what that address is, and then I just change this to use address. I don't have to set a static IP, and then ESP Home knows to overrule its own DNS name structure and always use that IP number. So yeah. So now I should also be able to view logs. Yeah. Nice. So let's see how it initialized. 254. Yeah, this is my own compile now. I2C running at 400 kilohertz. Okay. Yeah. Oh, it uses two I2C buses. Interesting. Nice. Yeah. Yeah, so one I2C bus is probably the top board for the inputs, right? The port expanders there. And then a second I2C bus is all the relays with the port expanders there. And the ESP32 does indeed support two I2C buses. So it's finding all the port expanders. GPIOs. Uptime, yeah, sure. switches. Oh, restore mode, right? But you can specify all of this in your ESP Home configuration. Okay, and it's still sending stuff, so likely my Home Assistant connection is still okay. So let's duplicate that, go to settings, go to devices, ESP Home, BoneIO. Yep, still works. So although I wasn't able to adopt the configuration because I don't have the MDNS stuff, because I basically inputted it in ESP Home myself from the GitHub, because it's the same configuration we flashed basically, and then have the use address in here. Basically I've now adopted this configuration. Of course, if there would have been changes on this device that this ESP Home didn't know about, you would have overwritten those. But since we freshly flashed it, it's basically doing the same thing. And now we can change all the things in here and just hit install and flash wirelessly, and then it'll flash it right here. Cool. Let's see how that temperature sensor is doing. Oh, it's a nice smooth graph. It's pretty warm here, 24 degrees, so that looks about right. You can see the voltage. That's pretty cool. And you can see the amps. This was probably when we were playing with all the relays. And that doesn't make that much of a difference. Current power, yeah. Shunt voltage, okay. Don't know what that does. It's, you know, it's not cheap. I wouldn't say it's pricey. It's just not cheap, right? So I think we're going to round off this section because we've basically looked at all the basic functionality now. Yeah, this is a input and output board if you want a lot of inputs and outputs for your home or whatever else you're building that you need, I believe 35 inputs for, or 32 outputs. And those outputs, as we discussed before, you put COM here, and COM can be 12 volt, 24 volt DC. So, and then you have two DC outputs. So then you just put ground to both of them, and you can switch the positive on and off. Or you can put live here from... Oh no, it didn't go through. Anyway, you can put live here and then have neutral and earth still going to your device. And then you can switch two of the lives here from one input. And that way you can switch all kinds of stuff, right? It doesn't have to be AC, it can also be DC. And you can switch a lot of outputs. So yeah. Thanks anyway, Neil. Yeah, if you compare this to anything commercially available, although that might be a PLC, and the real PLC, of course, has some more functionality than an ESP32, or maybe more robustness. Although with ESP Home, I've had devices running for years without a problem. Still, I wouldn't call this industrial, but for home usage, I run my whole home is running on ESPs. So, I mean, DC 30 volts. Yeah, I wouldn't. I just say 24. Maybe the relay supports up to 30, but they get sticky and stuff. So, just say 12 and 5, 12 and 24. I don't know. Right. Pretty cool. And the design is awesome. And yeah, I mean, I'd say it's not cheap, but I wouldn't say it's pricey. Because if you wanted to build something like this yourself, well, you'd have to build it. It costs you a lot of time. It wouldn't look or feel nearly as slick as this. And this is all pre-programmed, and they have lots of guides and everything available. I mean, if you only need 1 or 2 inputs and 1 or 2 outputs, yeah, well, this is massive overkill, isn't it, right? So you wouldn't buy this. But if you are actually serious in doing a project where you need 30 inputs and 20 outputs, I don't know. Cobbling that together yourself will be a giant mess. Especially if you also want to include Ethernet, stability, power conversion, pool highs, optocouplers. You can't breadboard. Okay, maybe you can breadboard it, but it will certainly not be reliable. Okay, let's leave it at that. So yeah, it's not cheap, but I wouldn't say it's pricey for what it is, especially if compared to other offerings, right? Yeah. With care not to mix 24 and 12 volt alarm sensor and 12 volt, it could work with Alarm IO. I don't know what Alarm IO is, but maybe. In theory, it's an ESP32, and as long as you run the same as with my boards, I give you full open access, just like BoneIO does. If you have code that understands the I2C port expanders, because the inputs and the outputs are all behind port expanders, you can run any code you want. Do you want to create your own Arduino sketch? Go right ahead. You just include the libraries for the port expanders, and done. You can run any code on there you want. If you want to run MicroPython, as long as you can do I2C in the port expanders, no problem. So in that sense, it's a very open platform. And since it's running ESP Home, it's natively tied into Home Assistant. Yeah, I really like this. I thought I was going to like it. That's why I said yes to send it. But, you know, I only like it more after actually playing with it. This might be an alarm board if it had a supervised input. What's a supervised input, Neil? Yeah, Piotr, I understand the desire for a smaller version. They might make one at some point, but I'm just talking from myself here. I think the reason is the margins on smaller boards are lower than on higher boards or higher port count boards. So one is margins, but then you get the same amount of support and other issues with them. So that's why generally selling a higher port version is better for the business than selling a lower port version, basically. Even if prices would scale linearly, which they don't, because all the hardware in here you basically still need, even though you're doing a smaller port version. So the per port price would have to be much higher than the per port price is on this one, right? So, yeah.
Remember all the happy times we had?
Well, Neil, these are pulled high. So they measure 23 whatever volt. And if they don't... oh, wait. No, okay. No, yeah. Well, you could make them shorted, so always active. So if then ground is cut or the positive wire is cut, doesn't matter. If one of the wires is cut, the connection is open, it doesn't read the voltage anymore, and thus it triggers the output. So in theory it could work for that. That's fine. No, it doesn't have to have a resistance. It just senses the voltage. So if there's a loop, there is no volt because ground, bypasses the pool high. But if it's cut, yeah. The NC zone? No, they're all NO, so normally open. But I'm talking about the inputs, not about the outputs. Ah, okay. Well, maybe I don't know the use case. There are ADCs on here, though. There is an I2C ADC in here, so you have some ADC pins, but not a lot. Yeah, okay, I think I get what Neil is saying. The other boards have some kind of special sensing circuit there. Don't know. Okay, I'm going to turn it off. I think that is it for BoneIO for today. Yeah. So far, I only like it more than I already did when unpacking it. Why did I go here? You couldn't see me. Hello. I'm still here. The live stream isn't over. No, I clicked the wrong button. Okay, yeah. That was stupid. Did somebody leave already? Don't leave. No, 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 no. Damn it. Okay. What I also wanted to look at today, just for a little bit of fun, is these guys. And these are USB-C input PD triggers. And I got two, and they basically, they kind of look the same, but one has the chip on the bottom, okay, and then some resistors here, and some other stuff, okay, but this one doesn't. It just has the guide how to select the voltage you want on the output. Okay, but then where's the chip? So I'm thinking, because this is a through-hole thingy, the dip switches here. I'm thinking it might be underneath there. Because that's a really compact design, right? Because this one I understand. You have the dip switches. Okay, USB-C output terminals, and then here on the bottom you have the IC you need, some resistors and things like that. What IC is this? I believe they selected a specific version. Let me take a look. Yeah, the CH224K. I believe that's a USB-C trigger, or a USB PD trigger. So is this all underneath here? Now in theory I have multiple of these, so we can, wreck it later. But let's start by testing it. I guess we'll test this one. And I want to test 20 volts. So we need slider 1 to go up and the others to go down. Is that slider 1? I don't know. I'm just going to assume. I'm going to assume this is slider 1, 2, and 3. Because the arrow points up. So on here, that is 1 goes up and the other 2 goes down. So in theory, if I plug this in now, we should have 20 volts on the output. Right? Oh no, I lost a lot of viewers. No, come back. Okay. So we have our trusty little tester here. And if we plug it in like this, because I have a little special board here. Let's first test our power output. If I plug it in, and this will be funny. Wait, I need 12 volt. Hold on. This will be funny, because if I short circuit my charger, my cameras are also on the charger. So if suddenly the screen becomes black, I blew up my charger. Okay, so this is my power tester, and it comes with a little board so you can input USB. Currently, of course, because there's no negotiation, we're getting 5 volt whatever. So let's say I want 1 amp. Yeah, that's 2 amps. Okay, I've got a little bit of voltage drop. It's okay. 3 amps. Okay, more voltage drop. 4? Oh, this charger doesn't care. 4 amps. Yeah, this charger really doesn't care. It's just giving me 5 volts, 5 amps. Okay. Will it do 6? Okay, it won't do 6. Okay. Now, it's not really supposed to do that, but it does it anyway. Now, what we can do... uh-oh. If I can find my thingy... What? Where did it go? Oh, yeah. You think it's in reverse? What? Oh, the display is upside down. That's okay. If we take this guy and then plug this in here. No, don't go into that. Okay, oh, okay, I guess you can. Anyway, okay, let's go into here. Well, I don't want that. Hold on. I want PD protocol, PD 3.0. Okay. Doesn't want to do PD. Now, I've seen this before. Okay, let me try something. For some reason, sometimes these cables don't like it when the display side is on the client device. Oh, you think it's in reverse, the dip switches? Well, we'll see. So let's try this again. Oh, now it's okay. Now it's saying PD fail. Okay, so I need to reverse the cable again. These are from AliExpress. These are from Besus. But if you want another brand, there's a brand called Toki, T-O-O-C-K-I, I believe, that also makes decent versions. Ah, okay. This is what I was looking for. Now I can specify the USB-C trigger manually because I have this device on here. So now I can say, okay, let's go to 9, 12, 15, 20 volts, 5 amps. Okay? Yeah, the silicones are great. Okay, so now if we plug this in... Oh, it's still on. Oops. We now have 20 volts, right? So this little trigger board is saying, take USB-C in, negotiate. I want 20 volts and then inputting it into my tester. And now I can say, okay, give me 1 amp. But 1 amp actually gives me 20 watts. 2 amp, 3 amp, 4 amp, 5 amp. And there we go. We have, well, if you could see it, almost 100 watts of output. So this is basically just to show you that the cable I'm using and the charger I'm using is actually capable of 20 volt 5 amp, right? Because we can test the trigger board, but we first need to know that we can actually do what we want it to do. Okay? So, yeah, no problem. We're doing 20 volt, a little bit of voltage drop, not that much, with 5 amps, so 99 to 100 watts. Great. Awesome. Cool. Okay. So then we don't need this anymore, because in theory this is going to replace this. Okay. So now let's plug in this guy. And in theory we should now have 20 volts. Maybe? I don't know. Let's take our multimeter. I don't know what plus or minus is. It's not on the board. Jesus. -9. Okay, we get 9 volts. Okay. So maybe Mr. Revenant's right. So we put 1 down. Let's see what we get then. 5 volts. Okay. And we put 3 up. Let's make sure the others are down. 3 up. Okay. Oh, I hear thunder and rain. Oh, now we're getting 12 volts. What? How many ways can we read this? Wait, guys. Oh, okay. Let's see here. 12 volts supposed to be the middle one. And the other one. Wait, oh. So maybe up means down. So maybe... because we're getting 12 volt now. But that's the middle one. What? Okay, I'm just going to try another combination. I don't know. It doesn't make sense. Okay, we're still getting 12. Let's put them all up. 12. Okay, let's replug it. $20. Okay. So all of them up is 20. What? Makes no sense. No sense whatsoever at all. Okay, sure, that's fine. I'm gonna take a different tester because that has a pre-attached cable. Oh no, the screen has come loose. Well, you weren't wrong, but you weren't right either. I wasn't wrong either. So I forgot what plus was. Let me check. I believe the bottom is plus. Yes. Okay, good. Now we're gonna jank this because that's the way how we do it. Okay, we need to unscrew this. Bottom is plus. Okay. Okay. Turn the tester on. I have one that's maybe broken, testers, but we'll see if that's this one, I don't know. Let's plug this in. 5 volt, 12, now it's 12 volt. What? What? Okay, I'm just gonna play with dip switches. Okay, so 1 needs to be down, and 2 and 3 need to be up. And now we're getting 20 volt on my tester. I don't know, man. I don't know. This is confusing. Okay, let's go 1 amp. And let's get the thermal camera ready. Because, you know, that's why we're here. Oh, I need to. Yes, good. Put on some protective glasses. No, I don't think it'll explode. It's not that bad. Okay, so we have our thermal camera thingy. Currently the plug is the hottest. Oh, the chip isn't visible, so we don't know where the chip is. Okay, that's fine. So let's go to 2 amp. Well, let's go. 5 amps. Give me 5 amps. Now I know these plugs heat up somewhat because of the display in there. But I'm wondering how much the board is going to heat up. So far it's, you know. 36, 37, but that could actually be from the USB meter, because that one is also heating up, so, you know. It's not very spectacular. And the warmest thing is the plug, is the USB-C plug itself. Hold on. Yeah, 40 degrees, that's fine. 41. Okay, well, let's, you know, leave it do that for a little bit. Oh, we got our viewers back. Nice. Welcome. We're testing a USB-C PD trigger from AliExpress that's like $2 or $3 to see if it'll actually do 20 volts, 5 amps. And so far, it's doing just fine. Who knew? Draadstal, you still here? Yeah, part of the board heating up is probably from the USB plug itself. Of course, there's a connection there, so that always heats up a little bit. Oh, okay, good. 45 degrees? Sure. But then the plug is also 41, 42-ish, so can't really blame the board for that. Yeah, that's not too bad. Okay, that's why I kind of wanted to add it into this video or live stream. I didn't think it would become very spectacular. I mean, with 5 amps running through there, 45 degrees is just fine. No problem at all. And as I said, part of that is because of these plugs, because I know these displays, they have to do some voltage conversion in there, and so they get a little bit warm. Yeah. At least now we know. Exactly. And I mean, I can bother testing the other one, but it has the exact same chip. and basically the same layout, and I think it's basically the same thing. I think what they did, and you can somewhat see that that this is a little bit lifted. They just put the IC under here and all the components, making it, you know, a one-sided component board. Let's tear it apart, shall we? This has been testing long enough. 5 minutes, if it works for 5 minutes, I generally test for at least 10, but I think this will be fine. Ooh. Okay, let's kill all this, kill that. There. Okay. Good. Okay, well, let's have that cool down a little bit. At least now we know. So now let's take it apart. I'm just going to do that the very crudest way I can do that. Okay, this is cooled down. And I'm just going to chop at the legs as far as I can reach them. This is a really tiny device. I figured I could maybe just go for the legs, but maybe I can't. We're going into wrecking mode. Oh. Wow, the rain and thunder is really picking up. There we go. There we go. So it actually seems the chip is almost embedded in here, because it has some spacing for that. Okay. And then they have a smaller version of that chip. And I guess they also need a lot less resistors somehow. That might actually be built into this switch. Could be. That there's resistors in here. And then they just have the little tiny chip. Which I definitely destroyed. It's okay, I have more. Can you guys hear the rain? It's really going. I think there's goo on here, or they lasered it off. It's not here yet. Well, yeah, it's raining pretty hard. Okay, let me see if I can identify this. No, I think they lasered it off. Okay. That's okay. Yeah, but that's a really nice and tiny chip to do USB PD. That's interesting. It doesn't seem to need a lot of extra components. There's a diode here that I broke off, it seems. Yeah. Oh, there's more components on there than you think. There's some resistors all around that IC. Capacitor. Oh. Still, it's not a lot. Okay, cool. Well, that concludes that part of the live stream. Wow, it's really going. What does it output now? Nah, nothing. We're not going to test that. So, I thought that was interesting. Something else than LEDs for a change. Oh, right, I still need... Philip normally reminds me, but I guess I still need to show a secret, huh? I didn't really prepare a secret, but... Well, I've been working on something today. I guess I can get it. I can get it. Hold on. Okay, so as I mentioned, Diff Advanced is currently in production. So that basically means the form of it is done. And I thought it'd be nice. I will not be delivering them with a case, but maybe some people would still like a case. The rain is starting to get here. Cool. So I've been working with a paid designer, but I thought, you know, it'd be nice to have some nice cases. This is the Diff Advanced Sender 4. It's not the latest prototype, but it's pretty close. Or at least it's the production version is slightly different, but yeah. What I do have is a 3D printed version of the production model. Now, it's not 100% accurate because I'm going to use different screw terminals, which are a different height, etc. And I still need to adjust that a little bit. But this is basically a board, you know, it's basically this board, but then 3D printed, so I can get, you know, some test fitting done without having the actual PCBs right here. And I've been working with a paid designer who has made a little case here, like this. I printed it in 2 colors just for fun. This is some sparkly, like we did the hexagon light, or the, yeah, I think it's a hexagon light. The cube light? Yeah, the cube light, yeah. And this is in green, I don't know. And, we can put this in here. There. And then we can, you know, close it like so. And if you thus want to have an enclosed Diff Advanced Sender 4, you can 3D print this. I'll make these files once the final version. This isn't yet the final version. There's some changes that need to be made. If you then have your own 3D printer, you can print this. Or maybe, and that's what I'd like to hear from you folks, it would be interesting if we could print them and then add them in your package for a small fee. Would people be interested in that? No, I just give the print file to anyone who wants it. You don't have to purchase it. You don't. It doesn't make much sense if you don't purchase it, of course. But yeah, the print file would be available, so you can print it yourself. And for people who don't have a 3D printer, we could, you know, maybe have it printed for like $1 or $2, and then add it in the package. And I'm just wondering, would people be interested in that? Because a lot of my boards don't come with a case, but some might want one. And of course, for the Dig Uno and the Dig Quad, there's lots of 3D printable cases you can find online but then you have to have a 3D printer. Now, a lot of people have those nowadays, but not everyone. So I was thinking, like, okay, and especially also like seeing the BoneIO, the quality you can get from a good 3D print and 3D model is quite high. So that's why I'm paying someone to design this, because I suck at designing 3D models for printing. But yeah, this is basically that board in here, right? And as I said, there's going to be some slight additions. Like, I want the Ethernet port to be slightly different. There needs to be a little notch here if you have a plastic lip on your Ethernet. Otherwise, it won't fit that nicely. I want something slightly different over here. Oh, and I wanted to have an option to have screw holes or a hook loop for Velcro on the sides, so you can strap it down basically, and some ventilation here. And this isn't the final version yet, but yeah. Okay, cool. So I'll consider that once this is final, and then I'll probably do it for the other boards too, and we'll do it as a little tryout basically, I guess. How people, if people like that. Because, I mean, this is printed on my printer at home. Now, I have an X1C Carbon from Bamboo Lab, so that's a pretty good printer. I believe BoneIO also uses X1Cs, or at least Bamboo Lab machines. And they deliver great quality. Cool, and you wouldn't mind that it would be 3D printed, ORL? As long as it's, you know, a decent, this isn't flimsy at all. I mean, you know, a decent version, basically. Well, bare wouldn't need a case. Bare would just be the bare board. And I'm hoping to have a sort of screw Velcro combination. But we'll have to see how that works out. I'm working with the designer on that. Cool, yeah, okay. This, I mean, it will probably just be some boring color. Or the cheapest color. But yeah. Cool, okay. Well, that's kind of what I, you know. You like a clean case. Okay, yeah, yeah. Right, okay, sure, cool. Okay, so I wanted some feedback on that, and I got this version today, so I printed it. And it's pretty cool. I like it. So for the Diff Advanced line, I'll probably make that available. And then for the future, I'll see what road I take with that. If I know a product is going to sell 1,000 or more, or like thousands, like the Dig2Go, I can do custom molding, that's no problem. But if it won't have that volume, or it'll take years to have that volume, investing like 10K or whatever in custom molding, it's just too expensive. It'll eat all the profit margin, the little bit I even make. So it doesn't make sense. If I can spread that out over 5,000 copies, sure, then it makes sense. But if I can only spread that out over, let's say, 500 copies a year, that makes it very tough. So then maybe this can come to the rescue, because a lot of people will just use the bare board in their otherwise cases and whatever they're building anyway. And I think this could be a nice alternative for people who don't use it in a big box. Maybe. I'll think about it, Draadstal. But yeah, so far this is nice and sturdy. It's the guy who made it, you know, clearly done that more often. And I like having the pegs here. And one of my additions was having a peg over here too. And they basically slot together so that when the board is in there, it's all snap fit. You don't need any screws, etc. And the board is actually held in there tightly and doesn't move because it's pushing from the bottom and the top, right? Logo's a must. Okay, yeah, sure. Well, maybe I'll put something QuinLED on there. QuinLED still doesn't have a nice logo. I never got around to making that. But maybe I can put some Queen LED on there, you know. And maybe the board type. Cool. Okay. I'm going to go listen to the rain. I don't know. Thank you all for being here and joining along. Even though we looked at a... Well, it's not a sponsored product. I don't know. Something that was sent in for free. I rarely do that, as you guys know. But I think this fit the channel really well. And I just wanted to take a look at it. Because, you know, I'm in the market for a new house. And anyway. Yeah, thanks for joining along. Thanks for testing and destroying a PD trigger charge. And I hope to see you back in the next video, in the comments, on the Discord server, or the next live stream. Thanks, guys. Bye-bye.